Hello everyone. In this video, we are going to see number conversions decimal to binary. So you have two different methods to convert decimal to binary. That is, one is sum of powers of 2. Second method is repeated division by 2. Then also you are going to see how to convert decimal fraction numbers to binary. So all these you are going to see in this video. So first method you are going to see sum of powers of 2. Okay, so we'll take an example here, convert 43 base 10 to binary. So here you can see that 43 is a decimal number because you can see a base 10 which indicate it is a decimal number. Okay, so once before you start you have to just write these numbers. So what are these numbers? Is nothing but it is nothing but the two powers of 2, that is 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16. So it goes on like that. You have to just fill in the numbers like that. Okay, from right to left. Okay, once you do that, you where to stop. It goes on like that. You cannot, you may not know where to stop. So what you can do is, you see the question. So here it is 43. So you are going to stop till the nearest, that is the closest value to 43, maybe 32 or 64. But you can see that 64 is greater than 43. So you can go stop till 32 because you are not going to use beyond that. You are going to use only till 32. Okay, so you can write from 1 to 32 for this question. Okay, now you are going to start. Now first what you are going to do is you are going to find the closest number for 43, that is 32. You have to subtract that. So 43 minus 32 equal to 11. So this is the answer what you got. Since we use 32, you have to put 1 there, 1 below 32. Now you got the answer as 11. Now you are going to find the closest value closest value to 11. So you got 16 and 8, but 16 is greater than 11. Okay, so you cannot use this. So you have to use the next number, that is 8. So you can write 11 minus 8 equal to 3. So here, since you did not use 16, you are going to put 0. Since you are using 8 here, you are going to put 1 below that. Now you got the answer 3. Then you got 4 and 2 as the closest number. So since 4 is greater than 3, you cannot use 4, so you have to put 0. But you can use 2 here because that is smaller than the value 3. So you can write 3 minus 2 equal to 1. So since you use 2, you have to put 1 below that. And then final answer is 1, which can be subtracted by 1. So 1 minus 1 equal to 0. So since you use 1, you have to put 1 below that. So after completing, you can just notice this 32. 8, 2 and 1 are the numbers we used. So straight to that the numbers should be. So under 32 you got 1, under 8 you got 1, under 2 you got 1, and under 1 you got 1. So this is the final value. So 1 0 1 0 1 1. The straight way you have to write it. That is the answer for the decimal number 43. So this is a binary equivalent for 43. Second method is repeated division by 2. So you have to take the numbers. You are taking the same example. So same 43. You have to keep on divide repeatedly by 2 till the quotient becomes 0. So what you have to do is you have to repeatedly divide the numbers. Write the quotient below, just below the number, and then write the remainder next to that. So you will see that. So you are going to divide 43 by 2. You will get quotient as 21 and the remainder as 1. Okay. So you have to put an hyphen and write the remainder by the side. Next, you can divide 21 by 2. So once you divide it, the quotient becomes 10 and then the remainder is 1. Okay. Then again you can divide because the 10 is greater than 2. So you can divide that. So once you divide that, it becomes 5. Quotient is 5 and the remainder is 0. You don't find any remainder because an even number, obviously the remainder will be 0. So next you got 5, which is greater than 2. You are going to repeat it again. So 5 divided by 2, you will get the quotient as 2 and remainder as 1. Again you are going to repeat the same method, that is, you are going to repeat it by dividing by 2. So 2 divided by 2, the quotient is 1 and the remainder is 0. And finally you have 1 here, that is smaller than the divisor, that is 2. So when you divide it, what happens is you will get the quotient as 0 and the remainder will be the same number, that is 1. So the quotient has become 0. So here you have to stop the repeated division method. So the numbers which you got, the remainder whatever you got, should be written in bottom to top order. That is, from the bottom you have to write the numbers in reverse order. So it should be 1 0 1 0 1 1. So you can see that number has been written in binary form. So you have to write the base 2 here to show that it is a binary number. So this is the second method. Now next is if you want to convert decimal fraction to binary, what has to be done? So you got a question here. Convert 0.375 base 10 to binary. So this is only the fractional part given here. Okay. So what you have to do is, since it is a fractional part, you are going to multiply it by 2, not divide it by 2. You are going to multiply that. So we are going to see that. So 0.375 should be written into 2. So multiply it by 2. The answer what you are going to get is 0.75. Okay, this is the answer what you will get when you multiply this. Now you are going to take this integer part. So integer part you have to take it separately. You have to keep it by the side. Okay, write it by the right hand side of that answer what you got. Okay. So then what you have to do is you have to do this repeatedly till this fractional part becomes 0. Okay. So this is also same like your repeated division where the quotient becomes 0. Here this fractional part should become 0. Till that you have to keep on multiply by 2. So next step again you can see 0.75 into 2 which will give the answer 1.5. Okay. So now the integral part you have to take it. That is 1 has to be taken and should be written by the side. So the remaining number is 0.5. Okay. Since you took the integer part away, you will get 0.5. That has to be multiplied it again. So you can see 0.5 into 2. So that becomes 1.0. Now once you take the integer part away, so you have written 1 here. Now what you got remaining is 0. Okay. That means the conversion is completed, because the fractional part once it becomes 0 the conversion is over. Now you have to write it in top to bottom order, that is 0 1 1. So the reading down the integer parts, the value for 0.375, the binary equivalent is 0.011. So you have to write as it is and then write the base 2. This is the way you will convert the decimal fraction to binary. Now next, if you have both combined, that is you have 38 integral part and fraction part 21. So you got a question here, convert 38.21 base 10 to its binary equivalent. So what you are going to do, same thing, integral part you are going to divide, use repeated division method, and fractional part you can use multiply by 2. Now you may be asking a question, why can't we use sum of parts or 2, which is easier? But if the question doesn't specify that what method to be used, you can go for repeated division method. Okay, so that's what they will be expecting. Okay, now you are going to first solve the integral part. So 38 divided by 2, so what you are going to get is the quotient is 19 and the remainder is 0. Again divided by 2, you will get the quotient 9 and remainder is 1. Again divided by 2, you will get the quotient 4 and remainder 1 again. Then divided by 2, you will get the quotient 2 and remainder is 0. And divided by 2, you will get the quotient 1 and remainder is 0 again. And then again you are going to divide it. You will get the quotient 0 and remainder 1. So this is the answer you got it for 38. So you have to write in from bottom to top order. So 1 0 0 1 1 0. That is the answer for 38 base 10. So that is the binary equivalent. Now you are going to go for the decimal, that is fractional part. So you got 0.21 into 2. That is nothing but 0.42. So the integral part has been taken away. It is written separately. So you got remaining number 0.42 again. Again multiplied by 2. So you will get 0.84. The integral part is taken away. That is 0 again. So you got 84 should be written multiplied by 2 again. So 0.84 into 2, that is 1.68. Now the integral part is 1. So that is taken away and you got 68. 0.68 should be multiplied by 2. So 0.68 into 2 equal to 1.36. So you are taking the integral part away and you are keeping it by the side. So remaining number is 0.36. So you can see that it keep on repeating. So you can go on for maybe 5 or 6 the integer part. If it still goes on, you can stop, because you know that decimal fraction part, the least number, the LSB will not have much value. So you can go on, try to solve for 5 or 8 up to 8 decimal point and you can stop. Now you can see 0.72, the integral part is 0. Okay, and then the remaining part, that is 0.72, can be written and multiplied by 2 again. So 0.72 into 2 is, the answer is 1.44. So 1 is the integral part, you have taken it away, and then you got the remaining is 0.44, which should be multiplied by 2, and again you got 0.88. You can see that it is almost same, right? That you then you can assume that it goes on like this. Okay, so the integral part is 0. Okay, and then again you can see that the value is 0.88 into 2 is 1.76. So you have taken the integral part away, and then you got 0.76. So it goes on like that. So it is never ending process. So what you can do is, after say 5 or 6 digits, you can stop. So just write the numbers in top to bottom order. So 0 0 1 1 0 1 0 1. So you have to just write like that, and then put the base value, and finally join both. 38.21. So the integral part binary equivalent and the fractional part binary equivalent can be written with the decimal point in between. So this will be the final answer for decimal to binary fractions. Okay, hope you understood these conversions. We are going to see binary to decimal in the next video. Till then, thank you.